thought if we can't get this to work, could we email you the slides and one of you could be the presenter and we just dial in and speak like a participant?
Yes, that would work, Daniel. Please, you can send them to me.
Do that. Send them over now.
No.
You finally got on.
Yay, we're here.
Sorry.
Hello.
Well done. I think Dan was making some
Yep.
contingency plans in the background.
Right, over to you guys.
Perfect. Give us one sec. Just sharing the content.
Are we started?
I think it's live now, so
Okay,
I can
cool.
I'll just do an introduction for you guys, and then you guys can have the floor and take it away.
Okay, thanks, Jared.
Yeah, the anticipation's killing me, so I'm looking forward to it. So good morning, everyone. Live from Sun City. I'd like to take this opportunity to thank everyone for dialing in. I know everyone is busy, and I'm sure this will be a very interesting and insightful session. And hopefully it sparks discussions, and happy to take any questions at the end if time allows. Hailstorms are one of the biggest risk exposures facing solar PV projects worldwide. Axis is a leading global insurer of renewable energy with over 15 years of experience providing specialty solutions for solar technology, have released a new report, Solar versus Hail, Pivoting Away from Danger. With insights from industry experts and cutting-edge claims data, the report deepens the understanding of hail risks in solar projects and explores strategies to manage and mitigate these exposures. As utility scale projects increase in size, moving from 75 megawatts, around 2 billion rand in material damage and BI, sums insured in round one, to iTOO Renew Risk writing the largest solar PV project in South Africa at 300 megawatts and 600 billion material damage BI in 2025. We have also seen concurrently that most new projects are being built away from the resource-rich areas of the Cape regions with little NatCat, SES, severe convective storm exposures to the hail, SES-exposed regions in the Free State and Welkom areas, to name a few. Learning from devastating hail events globally and global weather data, reinsurers and insurers can now start underwriting NatCat, SES exposures at sustainable levels. I was lucky enough to be in London recently at the Axis office, which just sits across the road from London, Lloyd's of London, when Axis gave me a sneak peek of this presentation and all the work they had put in. They were preparing to give a talk to their London brokers. It only recently dawned on me, why should the London brokers get this valuable insight? Why not our South African and African brokers? This is when I asked the Axis team if they would be willing to do an iTOOsday, which they have kindly agreed to. So please join us in welcoming our Axis experts, Tim Topham and Sophie Draper, to present their key findings. They'll also share how these insights influence Axis's underwriting approach with a special focus on the South African market. Axis have been a long-standing partner of iTOO Renew Risk and are our lead reinsurer on our best product offering. I'll just give you a couple of short bios of Tim and Sophie. Tim joined the Axis Renewable Energy team in 2018, working across both offshore and onshore renewables on the underwriting side. During that time, the team has grown into the largest renewable-focused team in London, with a gross written premium in excess of $300 million, supporting sustainable projects across the globe. Now solely focused on onshore MENA region, Tim heads up the African book, where they have been supporting iTOO RRA since 2020 and are our lead best insurer. Sophie is part of the global team of engineers embedded in the renewable energy team that provided support to the underwriters and customers for onshore and offshore renewable risks. She is responsible for the renewables claims data analysts and supports the production of best practice guidelines for existing and emerging technologies. Sophie recently won Global Market Excellence Value Award for contribution on the Solar vs. Hail report. A trained mechanical electrical engineer, Sophie joined Axis in 2024, bringing several years of experience in engineering design consultancy fields. She previously was a researcher and teaching assistant in the Department of Engineering in Durham University. Her research focused on the design and comparison of power conversion systems for wind turbines. She was an active member of the Durham Energy Institute. Prior to this, she is a mechanical engineer at AECOM. Sophie is a member of the Institute of Engineering Technology and Women's Engineering Society. Over to you guys. You can take it away.
Excellent. Thanks so much for the intros, Jared. I'm just going to get the screen share, so hopefully this should come up. Ooh. Is that showing for everyone?
Yes, it is. Thank you.
Excellent.
Cool. All right. Thank you, Jared. And yeah, sorry everybody about the technical difficulties. We will go slightly quicker than planned through the beginning bit. But yeah, just as Jared said, my name is Tim Topham. Good morning, everyone. And yeah, I'm one of the onshore underwriters here, the Axis Renewable team in London, and we are one of the reinsurers who support iTOO Renew Risk in South Africa. And the topic we're discussing today will be about the impact of hail on solar projects. And that title, Pivoting Away from Danger, that relates to a deep dive report we put together the first half of the year, which I believe has been sent to some of the brokers who might be on the call, but it's also available online for anyone who would like to go and look at it. And it's basically a deeper dive into what we're going to discuss today with a bit more detail. But yeah, it's available there. So I'll just begin with a bit of background, and then Sophie will go into a bit more detail on the claims data. And we'll finish off with just discussing more about our findings and conclusions about what we've learned over the years insuring renewables, and our key findings and what our kind of lessons learned on risk mitigation against hail. So yeah, as Jared mentioned, Axis is one of the longest standing renewable energy teams in the market. We've got over 30 dedicated renewables underwriting staff, and we're dotted around the globe. So we've got a lot of team in the US, with big base in London, and then we've got Dublin as well as Athens offices as well. And alongside the underwriting team, we've got 7 dedicated claims professionals, so that they work purely for the renewables team. And as well as that, we've got 5 engineers who have renewables industry experience, who kind of back up and support that underwriting side. So we feel that really gives us a 360-degree view of the risk, and just pricing for renewables insurance. And yeah, so this map kind of shows that we've got this global spread. We've been writing renewals for 15 years, and we've kind of expanded that global footprint. During that time, we've written over 158 billion worth of assets insured. And the point here is not just to show off how good Axis is, it's just kind of make the point that we have this global footprint. And as we've seen severe convective storms get more and more of an issue, especially hail, we've therefore been on the back of quite a lot of these hail losses. And we kind of feel it's our duty as someone who has this experience to share our knowledge and our findings with the rest of the market and developers and brokers, to kind of deliver that message on the key findings that we have from doing this for so long. And hopefully that will support the renewables industry in sustainable risk mitigation against hail. So just Sophie's going to go a bit more into detail, but there's some key highlights from what we've found. So these are from claims from the last 5 years. So hail's damage on projects we've been involved in 1.3 million PV modules. It's caused $342 million of claims on our book, as in on claims that we've been projects we've been involved in, and that's caused an interrupted capacity of 2.7 gigawatts. So yeah, it's a serious issue, and it's something that's become really high on our radar from about 2019 onwards. So NatCat claims, they don't actually make up that big of a total in terms of claim frequency on our book. I think it was about 6% from claims data from 2019 to 2024 from NatCat claims, but it's the low severity, but it's the low frequency but high severity, and it's that high severity which is why they have such a big impact on our book. So I think mechanical electrical breakdown claim, the average is about 500K in US dollars. Theft claims about 300K, whereas a NatCat claim, it shoots up to about $7 million. So it can really impact our figures. And if you see on the left here, this is average downtime. So basically how much has a project be interrupted following a loss, an insurance loss from one of these events. And you can see theft and vandalism is only about 78 days. MEB, it goes up to about 130, but from a NatCat, the average is about 240. So that's about 8 months offline. And so NatCat's vital. And as you can see on the right, hail makes up a really significant portion of that risk behind strong winds at second with 27%. So just going back a bit, just talking, this hail issue is becoming, with climate change, is becoming more and more of a problem, and it's not localized. It is a global issue. But you can see on this map here, there are certain areas where it's more, the modeling shows it's more important than others. But so the majority of our book is in the US, and that's where we've seen the biggest claims. And you can see from that map, that's where it is modeling is the highest exposure. So 55% of the NatCat claims we saw in the US were from hail. But it's not just a US issue, as you can see. Italy's had a 200% increase in large hail events since the 50s. And this is kind of been demonstrated in 2023, they had 6 billion euros worth of insured losses in the hail claims that year. And they had the record European hailstone, which reached 7.5 inches in diameter. Australia has also had issues. You can see there 7.4 billion in insured losses from 2014 to 2021. The market suffered a 25 million loss to a hail project back in 2022. And in places like Argentina, we've also seen solar projects being destroyed by hail. So it is a global threat, and you can see that South Africa gets a little bit of that on the modelling side. So yeah, just now the main focus of what they're talking about today is South Africa. So a lot of people no doubt be aware on this call of hail in South Africa can be very severe. We just had a look at some of the stats, and we saw that 7 out of the top 10 NatCat insured losses from the 70s have been from hail, and that total loss accounts for over 45% of all insured losses. So that's property and automotive losses. It's a big issue for crops and agriculture. So I think on average 2% of the annual crop is lost to hail. And in 2013 in the Gauteng province, sorry if I'm mispronouncing that, we saw tennis ball sized hailstones falling, and we had a 1.4 billion rands worth of insurance losses, which is $140 million. And yeah, just going back a bit, so solar in South Africa is about to grow, as I'm sure lots of you know. It's growing globally for a number of reasons, mainly because the barriers to entry have dropped quite considerably. Its solar growth is kind of outperformed forecasts year on year for about the last 10 years, and that's a lot to do with the lower barriers to entry dropping down, with the costs coming down massively. You can also deploy it much easier than other technologies like wind or conventional power. There's much more areas you can do it. And we've seen that growth is demonstrated by so the first terawatt of solar took about 50 years from the first project being built to reaching that figure. And then the second terawatt was completed in the next 2 years, from 2022 to 2024, which just shows the exponential growth of the industry. And the renewable energies growth is meant to be driven by solar. They expect by about 80% of that's coming purely from solar. So it is the kind of the driving force behind the industry. And in South Africa, you've got your renewable energy master plan, which is targeting 6 gigawatts of increased solar capacity by 2030. And so the problem we have, I mean, this is a good thing, obviously, for everyone who's involved in renewables, but the problem is about where are these projects going to go? And then how do we as reinsurers manage that risk, both from an aggregation perspective, but also just how kind of working out how exposed sites are. So we rely on modeling tools to kind of, when we first get a submission in, to kind of work out how exposed a site is. But the problem is that this data is still, it's not particularly great. And Jared and Trust will both tell you there's frustrations with we using one tool, another reinsurer we're using a different one, and they're saying 2 separate things. And this is because a lot of the locations where solar is being built are quite remote, and therefore the data isn't great. I mean, even in the US, they have fantastic data, but it was only after 2019 when the project started being built at a larger scale that we started to really see how exposed these places actually were. And we often get told in new territories, you know, hail isn't an issue here. We haven't had that many losses, but a hailstorm is quite a localized event. And if it's in quite a remote region, you're only going to get that feedback if if some property gets hit, and that's often not there. But if you think about what a solar farm is, it's essentially like a huge field of glass. So you're putting that into a remote region. I think we said a 100 megawatt site is the size of 500 football pitches.
Yeah, about 500 football pitches. Yeah.
So it's kilometers wide thing that you're putting into a region where there isn't much data at the moment, and then it's the utility scale size of these projects that is causing it to be a real a potential issue to massive losses. And so this map here is one we got from Gallagher Re, and it kind of shows the hail exposure in South Africa. So this return period on the right is for hailstones of over 1 inch, and you can see the whole kind of eastern side of the country is expected to receive hailstorms where you're getting hailstones of that size. Now, when you go higher than that, above 2 inches, where they get really damaging, this does reduce down, but you've still got that kind of hail belt on the Eastern Cape of the country where it's really bad. But even these yellow patches, kind of in the northern part of the country, there's still quite a high return period, but we still feel like quite exposed. And as you saw in the previous slide, the Gauteng, where they've had some of the biggest events, is that yellow patch in the middle there. That is where a site we're concerned about. What we know, there's a lot of projects being built in that region. So if we just flick on, we've got an overlap here of most of the projects, solar projects in South Africa. So these blue ones are operational, and the size of the circle kind of demonstrates the size of the project itself. Blue one's operational, the grey one is ones that are in construction, and purple are planned. So majority of solar projects currently in South Africa between 20 to 50, 75 megawatts. And we're now starting to see some submissions from the Renewers team that were like 100 megawatts. These ones under construction. And then next year, a lot are planned around this is going past 250. So it's a completely different exposure that we're dealing with. And as you can see here, these ones here in purple, that's kind of the similar region where we are concerned, and this is a problem for insurers. So we're getting submissions in, and it's like as Jared mentioned, is that these places like Welcome, Virginia, that kind of Gauteng province. There's a reason why that it needs to be in these kind of areas, because that's where the grid capacity is, and that's kind of where we need to move the projects. But then it becomes an issue that these are hail exposed. And then it becomes an issue for insurers with aggregation. So we have a kind of underwriting strategy where we can say, we're happy to have X amount of capacity deployed in a hail exposed region. But then if we have one project there and then another project there and then a third project there, you're kind of, your buildup of exposure increases, and then you're stuck with the issue of how much do we deploy on each project. And sometimes that becomes a case of prioritizing partners who we have a longer term standing with, we have a big portfolio and spread of risk, whereas another one, it might be a bit more tricky. So these are the issues that we're facing. And yeah, just to sum up on the challenges and limitations, there's three main issues really. Real world data, as I touched on already. The climate change is making these problems even harder to deal with, because even the data, which isn't great at the moment, is even worse by the fact that the climate's changing, and we can expect larger hailstones and more severe storms in places where we weren't expecting them before. Technology misalignment. So clients can invest in the best technology, but it's not just about investing in the tech. You've got to also invest in your operational and maintenance and your procedures, and test that technology is actually working as it's supposed to. And then the other side for us is the underwriting challenges, where I already touched on, about making sure we aren't over deploying our capacity and we don't have too much aggregation in one spot. And then it's making sure we're getting that critical information that we need from a risk submission, which is what we get from Jared and our brokers who might be on the call today. So hopefully not too much bad news there, but now Sophie's going to just jump into some detail on the risk and the tech and the claims data.
Yeah, so you're probably all wondering what these kind of damage looks like to these solar projects, and it can be quite significant. It can be quite nasty. This is a very, very large claim that we had from the US, which caused significant damage from a hailstorm across the site. And these are hailstones up to 3 inches. You're thinking about like the size of a tennis ball here. And these are using a more traditional type of PV module. And a PV module is just the kind of terminology we use on utility scale solar for a big solar panel. So they're big, much bigger than the ones that you'd see on like a rooftop. And the damage is so significant from these hailstones, which are also being flung with a force from the wind, that you can see the indentations on the back of the PV module. And then this was another case study where they had these large formats PV modules, but this have the dual glass instead. So we've actually got glass on the back of the module, and I'll explain a bit about that later. And these are kind of up to 4-inch hailstones recorded, absolutely massive. And the damage is so significant. Again, it's pushed its way all the way through that PV module. And it's not just a case of being able to somehow replace the glass. That's your full solar panel almost lost. Where there might be modules with just smaller cracks, you're still going to have a loss of production. So this is going to affect the site significantly. And when we analyze our kind of hail claim data, it's clear as you get larger and larger hailstones, the damage is going to be more significant. So as we move from the 1 to 2 inch, we're looking at on average about $160,000 per megawatt installed capacity. And then you just step up from 2 to 3, 3 to 4. That is just exponentially increasing because the hail is just so much more damaging at that level. It's going to hit the panel with a greater force, break through the glass, and then all the way through, including that kind of energy producing part of the module. And that downtime is reflected in that as well. It takes a long time to have to take these out. They're very heavy, and buy in new ones, replace them. They've got to fit the current mounting structure they sit on. So it really can lead to kind of a long amount of the kind of business interruption as well. At the moment, from our claims, we're kind of seeing mostly that these events are happening in the operational stage of the project and fall under the kind of operational policy. However, we're seeing an increased amount of events that are happening during construction. There's certain elements of when you're kind of constructing a solar PV project which can leave these PV modules more vulnerable. And that actually is resulting on an average larger claim amount for our construction claims on average, about 3 times the amount of an operational claim. So construction is also a concern for hail because of the vulnerability of these panels. So just a kind of state of the market where we are at the moment. I showed you some pictures of the of 2 different types of modules. We tend to see in the past kind of single glass. That means you have just glass on one side of the PV panel or module, and then there's just an opaque back sheet. So it's common what you would get on a rooftop, but these are also being deployed on ground solar as well for utility scale projects. Now we're very much moving to this dual glass, sometimes called bifacial, You have glass on either side of the PV panel, and it's great. It gives you far more energy production. You're going to get light bouncing off the ground. You're going to get more energy. However, when you double up on your glass, it increases your weight, and it can lead to more vulnerability. Thinner, weaker glass is far more common now, especially with these kind of dual glass modules. And when these are tested after a 2-inch hailstone is launched at them, some test results completed in a lab, a PVEL, kind of show that these new modules are more vulnerable and have a much higher breakage rate of about 90%. And they are dominating the market. We see them for almost all large utility scale projects now within South Africa. And they are more vulnerable to hail, unfortunately, because of this just different arrangement. And we've seen this as well with our claims analysis. With this weaker 2mm glass that doesn't have the same strengthening, we did see these higher average gross claim amounts. So about an extra $50,000 US per megawatt on average that we've kind of found. Now, simply, why is solar vulnerable to hail? And it's glass. You have fields and fields of glass, and Tim was saying about the size of these projects. And part of that as well is the actual kind of process that the PV panel or module has to go through to kind of get certified to be able to kind of sell. There's a kind of key certification that's used, and at most engineering kind of technology products, you're going to have to go through testing and certification. There is one test within this key solar certification, which is a kind of hail impact test. And all that tests for and requires is a 1-inch hailstone at a 23 meters per second launch speed. Now, this is not reflective of those big hailstorms and those events Tim was talking about earlier happening in South Africa and on a global perspective. So this might be adequate for, say, the United Kingdom, where we don't have large hailstones, and this is going to be absolutely fine. But in these vulnerable areas, it needs to go further. It needs to take into account much larger hailstones, the fact that often these events come with a severe convective storm, very strong wind speeds as well. So they can be fired at the PV panel with a much greater speed. It will increase the impact energy there and do more damage. And the fact that hailstones are not perfectly spherical, this test will make sure they're like absolutely under lab conditions perfect. Whereas what we see from hailstones is lots of spikes on them. We can see them being pointed, and that will kind of affect the impact damage. It's a bit like if you drop your phone flat on the ground versus if it hits the corner of a table, it's more likely to smash. So there are kind of higher grade tests available, but this comes with extra cost and they're not often opted for. And I think solar developers as well may not be aware that there are options out there which are more hail resistant. So this is something that's kind of a moving field. It's still early days, but it's pretty kind of agreed upon in the industry that the current certification for solar panels for hail exposed areas is inadequate. Now, there is a kind of other technology that can be applied to these big solar projects. And it's very common, as well as the dual glass now, that we move to tracker systems. So traditionally, a solar panel on a ground mounted project would be called fixed tilt. You have posts, it sits in the ground, it cannot move, and maybe facing like, a south direction, try and extract the most amount of sunlight throughout the day, but it's not optimized for the movement of the sun. Whereas your tracker really provides the advantage of moving with the sun throughout the day, and the energy yield is so much greater. So there's going to be a higher initial investment with the tracker, but you're going to get a lot more gains throughout the year. Pretty marginal operations and maintenance now on these things, but it still is a concern. But yeah, it's generally agreed upon. If you're going for a large enough project, it's absolutely worth the investment to move to a tracker. And we say single axis because it just moves in one axis, doesn't move all the way around. Now, trackers, from our kind of risk engineering perspective, are actually fantastic in many ways because you can move the panel to protect it from these perils, not just hail, but other things as well. Things like wind, it can lock into place so it won't move, sometimes horizontally as well. So it's got a lower surface area against the wind. Flood, you don't want the panel dipping in water, getting damaged. It is kind of an electrical component. Snow, that can build up as weight on the panel and crack it. So you want to make sure it sheds the snow off. But for hail, it's great because when you have an impact of something that's on an angle, it's just going to glance off rather than hit it directly. If you look at hail claims in the automotive industry, it's usually the main front windscreen that gets damaged significantly, whereas the side windows might get some damage, but not near as much. And it's just because it's glancing off the side. It reduces the impact energy. So this kind of steep angle, or stow mode we call it for hail, is very effective. It's also going to reduce the surface area and the potential for hailstones to strike in the first place. So it's very recommended that if you're in a hail exposed area, you opt for a tracker that can move into a steep angle when a hailstorm is approaching. And we've seen this from our claims data as well, where we have tracker scenarios where it's a trackers on the project and they've moved successfully into a hailstone mode of about 60 degrees. It's going to reduce the average claim amount from a severe event right down to about $150,000 per megawatt. Whereas if that tracker system doesn't work, it's about $380,000 per megawatt. Very similar to that fixed tilt where it can't move. The reason why the tracker stow failure is slightly higher usually is because then if it's not worked, it's not gone into that hail stow effectively across the site, you've got a bit more expense there to kind of replace things. So it might be motors get damaged and such things. Now, why do they fail or not work as expected? This is kind of an important part, a bit like what Tim was saying. You can have the right technology, but you've got to make sure it's going to be working in the correct way. Now, a key one is the site did not receive the weather alert in time. So they might not be using the latest cutting edge weather monitoring technology. It's also a very moving field, kind of meteorology. It's sometimes difficult to predict these storms. So that can be, it's often not the fault of the site entirely, but it's something that's got to be considered, making sure that that module has time to move into that stow position. Sometimes, though, it's actually a decision on site that kind of leads it all to fall apart. There may be a delay in initiating the hailstone mode. Sometimes it's a worry that, we could lose energy production by moving into a hail stow. It's sunny right now. There can't be a storm on the way, but that's not always the case. The weather can change incredibly quickly with these severe convective storms. And so there's a delay in this decision. Maybe there was not the correct kind of authority in making that decision. Sometimes as well, you get these big kind of wind speed events, tornadoes forming, and that just exceeded the design of the whole module. So it's really important these tracker systems and the whole design all the way through to the foundations can withstand strong wind speeds as well in these hail exposed areas. But we do see trackers that had failed before the event and the site wasn't aware. So things like rodents chewing through cables, there was maybe a disconnect from the grid and they couldn't power themselves into a stow position, or were just broken down. They maybe have not been prepared properly. It might be an error or a fault somewhere in the system or in the communications. And yeah, it just didn't move into that position. And that's why regular testing is so crucial with trackers. And we can really see the results of that when they do work. Now, the kind of claim data we presented so far is kind of reflective of what was available in the market, which is about 50, 60 degree stow angles. However, now we've got kind of manufacturers announcing stow angles over 70 degrees, 75, 77, up to 80 degrees. So you're getting even more vertical. And the more vertical, the better, really. You're going to reduce the kind of chance of that impact. Now, this is kind of a busy figure we've got here, this heat map, but it's showing a kind of along the left-hand side, the tracker stow angles, and along the bottom, the hailstone size. So if you have a horizontal panel and you've got a massive hailstone, 3.5 inches, you're 100%, that dark blue, going to lose the panel. It will be fully damaged by that hail. Now, as you move down and kind of to the left side, obviously smaller hail is going to be safer, it's going to be better for those panels, but the thing we can control here, either being the glass of the panel or the tilt angle, means that we really can, if we move even from 60 degrees to 75, make huge kind of protections, basically protection savings on the panel, reducing our breakage rate. So for 3-inch hail, which is very damaging, from 60 degrees, it's nearly 100% full damage and a high breakage rate. And then the 75 degrees, we're coming under 50%. And to the left of that, you see, so 2.5 inch, you're going from 50% damage to just 14. So that 75 degree stow is very, very effective. And this is kind of data provided by a kind of top tier manufacturer next tracker with a kind of research lab, RATC, who've been testing these different configurations. So this is good news story for us, seeing this technology coming through and seeing it work effectively. It's a very exciting time. So kind of talks mainly about the kind of appropriate technology, but the glue that puts it all together is that well-informed ops strategy, and making sure staff know those kind of protocols, procedures, and that the accurate forecasts are working. They have time to move into that steep angle, and kind of get the hail alerts working across the site. So we call these kind of our pillars of best practice. We go into them in more detail within our reports, but it's really critical that we see all these kind of three things together. Now, when we get our submissions, we love to see the good news stories. We want to see where this technology has been implemented effectively, and also doing very good recording on the site. So this is a real example provided by a customer of ours, where they were doing monthly tests on the tracker system to make sure it's moved into the hail stow correctly, and ultimately found very, very little losses in energy production from doing these practices, and from the just hail stowing when they thought there might be an alert there, which is a concern for the owners, that they might be losing production, but it's very, very minimal. And this was in a very high hail exposed area. And because they were using all the best technology, there was only 5% of projects where there was kind of damage, and that was from big hailstones. And generally a very, very high tracker stow success, because they were kind of checking the systems were working. So this is the kind of summary that we would be provided in a submission, which is very, very helpful for us. And this was from the 2024 throughout the year. They recorded all the hail stows, all the hail events, and they have monitors on site to measure the size of the hail as well. And there was only one very damaging event, which was in May, where there was very large hail recorded, nearly 3 inches. But there was only 0.05% of damage, and they were using a steep tracker stow angle. So it really just showed that testing your systems, implementing the best technology works, and then giving this back to us within a submission is very, very helpful. And this is alongside any other technology that's being employed. We're seeing things like drone technology and advancements, even the buzzword AI, but these tools can help, and all the data that we get, the better. It's important to share this within the industry too. So I'll hand back to Tim, who's going to talk a bit about the underwriting process.
Thanks. Sophie just shown this is what the data tells us, and a bit more detail about what we consider best practice. But yeah, just a bit more going back to the insurance side and how this all feeds back into our underwriting process. So I think the key message here is that we are going to differentiate between clients who basically based on that and according to how they mitigate against this risk. But essentially there's five key stages of our underwriting process towards hail. So it's firstly identifying and assessing that exposure, as I discussed before. That'll be from those models, and that's as accurate as we can do, based on the data we are provided with. So we do use those models and modeling tables, but we also use kind of like just literally like local news reports. So we just see the local town, see how much exposure they've had in the last few years, and it does get that granular at times. And then it's reviewing all the technical information, and that's going back to those 3 pillars of best practice. And the key thing to note about those pillars is that they are a 3 that we see equally. It's not you can't excel in one and then miss out on the other 2. You need to be hitting those 3 points equally as importantly as the other one. And then, as I touched on before, it's about monitoring our aggregation and the spread of risk. So we have to kind of keep track of where our exposure is. We've got a map which has all the details of every site we're on, and then how much exposure that each site has, and then it's about monitoring how much we're willing to deploy in that vicinity of that region, and then it will become about the pricing. So that will be how much limit we're going to give on this project, and that's your cat limit. So you'll have maybe a full cat limit, or you'll cut that down for a certain maximum loss you're willing to have for hail, and that can impact we can either lower that or increase that, but that might affect our line size we're able to deploy. So we might not be able to offer 100% of the risk, and we might need an additional insurer to support us on that. And all these kind of things combined, and if we have these aggregation issues, as I touched on before, it then becomes a case of that prioritization of capacity. So we want to support every risk that we can, but if it's going to be 2 projects in the same space, it's going to be the person who's mitigating against hail the best, and the person that we've got that partnership with in terms of a more long-standing relationship and a wider portfolio elsewhere. Next slide. Yeah, so this is kind of the key point I think most brokers want to hear about, is what it actually means for their clients' terms. And yeah, I think this is still just to reiterate, each risk is still going to be underwritten individually and evaluated on its own merits. Yeah, we often get asked at the end of these events, kind of, if my client installs this particular tracking system or these specific modules, are they going to get what discount are they going to get? And it basically it's not an answer that we can just give X panel equals this discount. We still have to, going back again to those 3 pillars, it's about hitting those three pillars of best practice that we've settled on. But yes, essentially, clients who are doing their best to mitigate the practice are going to receive favourable terms from us, and then they're the ones we're going to prioritise. But it's not just about premium and pricing. There are other ways we can assess. As I talked about, those cat limits, you can have a higher or lower cat limit, or about the capacity we can deploy. We've also had examples where we've actually offered a lower deductible in cases where we can prove that the client was being prudent. They bought the best tech. They were aware that there was exposure to severe storms, and they had that on their radar, and everything stayed properly, but yet they still had a loss. And in that example where they've done all they can, they've acted prudently as a client, and then we've actually said if that's the case, then we have the lower deductible for the hail. But yeah, so I mean, I think that was the last slide. But I think the message is really simple. Yeah, it says clients who excel equally across those 3 areas, and you've identified the most, they're the ones who are going to see the most favourable insurance terms. But yeah, the main drive around this talk today, I hope it's been informative, was to derive the collaboration. And as I touched on at the beginning, it's all about, we feel it's really important for us in this industry to share our knowledge and collaborate with developers and with brokers. And we feel like it's so vital for the industry to grow in a sustainable manner. And I feel like South Africa's in a fantastic position. It's got the backing from government. It's got you've got a lot of space. You've got the sun. You've got everything ready for solar to be really successful. And yeah, everything's there. So yeah, we just hope that we can do our part by sharing the lessons learned over the 15 years we've been insuring solar. Yeah, I hope that was informative. And yeah, as we got up here, this is the link to our report, which goes into much more detail with much more examples. And we probably did speed through that quite a bit, so you might want to just go back and check that out. Yeah, please do. But thank you very much.
Oh, thanks so much, Sophie and Tim. That was great. It was really informative. I just got a question from my side, and I see also Alex has got a question there, but you might have touched on it, but maybe I missed it. But if they're stowing at 75 degrees and the wind's coming at such a velocity, are you not seeing claims from wind damage to the trackers?
So yeah, so it's a really, really good question, and we get asked this a lot, especially that a very common for trackers wind stow angle is the horizontal. It kind of feels like it makes sense. You're reducing the kind of area that the air can kind of push on. However, what can happen with that is that you get this kind of event. It's like a torsional kind of oscillation. It's kind of called galloping, and it's almost like the wind effect from the above and below can cause it to move, and it can damage the tracker and it can damage the module. So it just depends on the design of the tracker. But either way, it must be designed to withstand certain wind speeds. And the hail stow command generally now, and it's still a moving field, it's kind of agreed by tracker manufacturers as a priority because it can do more damage than the wind. So it's not just the panel itself and the tracker. It's got to go all the way down to the foundation to make sure it can withstand wind speeds. And some tracker manufacturers now are doing the same. They are designing the whole system so it locks into place at 75 degrees. It can withstand hail and it can withstand very, very high wind speeds. And from some of the test data from manufacturers we've worked with, they have been proven to kind of survive like hurricane level force wind while kind of protecting against hail. So from kind of our risk engineering perspective, it's great when you have a kind of alignment in a kind of risk mitigation. You're not prioritizing something over the other and potentially exposing yourself to the other risk. You're protecting yourself from both. So I would say, like, from my risk engineering perspective, definite preference for wind and hail in the angle to be the stow angle for both and designed for both. It's very critical. So we go into a bit more detail about the wind protections within our report as well, if you're interested.
Okay, brilliant. Thank you so much. I see a question from Alex. He says, are you seeing that post-claims panels are being replaced with plastic modules and not traditional glass, organic modules?
We haven't seen that yet, but I think it's quite an interesting idea. There's always new technology in this space. I think the reason why glass is used is because of the purity. It allows light to come through, because at the end of the day, it's still got to be an energy producing device. If you use a kind of fully strengthened tempered glass, a bit like what you get on a car, it's almost like a safety glass that's smashed into small pieces, still has a very high clarity. So you're not blocking light from getting to that cell and that energy producing factor. I think very, very pure clear plastic still has, I think it's a high level impurity. It's almost like you can kind of see that sometimes if you look through like a sheet of clear plastic or a plastic cup rather than just a glass. So that's probably a large factor in it, I imagine. But there's always new materials and developments. We love kind of keeping on top of this space, learning what's out there. We're also learning about organic solar cells coming through. And unusual technologies that are moving away from the silicon kind of standard solar cells. So they might come with a different type of glass or technology altogether. So we'll see what comes from that. But yeah, it's an interesting thought.
Amazing. Thank you so much. I don't know if anyone else has got any questions they want to pose to Sophie and Tim or myself. We are here to answer all of your queries. Yeah. Don't know if Zintle, can everyone speak?
Oh, there's one. There's some in the chat I can see. So someone's asked, Louisa said, what else can one do to protect the solar panels from hail damage? So yeah, as well as the kind of having that kind of glass that's effective and can withstand hail, implementing the tracker. It's about the kind of site procedures in place. So for instance, something didn't mention about was having kind of an interruptible power supply, so that tracker is going to work no matter what happens with the kind of connection to the grid. All staff on site are aware of kind of hail damage. These hail events tend to hit at night. So if you're in construction, it's putting PV modules and equipment in a sheltered area. If they're like flat on the ground in pallets, because we've seen that as well, where these PV panels and modules are damaged just in laydown because they haven't been installed yet. So there is kind of a variety of things that can be done with that. But yeah, sometimes things like nets come up, which are used in kind of agriculture, but it doesn't really work for the size of these projects because they're just so large. And again, it would impact the energy production. Is it worth that cost investment? Really, we should be investing on the glass and the design of the panel as well as utilising the trackers.
Thank you. There's another one. Oh, there are quite a few coming through now. Do policies contain a tracker stow warranty?
So we don't have it as a specific, but it's kind of like that deductible I was talking about, where that this is kind of where our policies aren't just it's very we can kind of like add stuff in based on during the underwriting process. So it's like that deductible that we added in was kind of because we had a long ongoing discussion with the client at renewal, and they'd invested a lot in that tech, and so we kind of think it's only fair that if they're doing everything they can, to act prudently, then that's why they should get preferential treatment and preferential terms. And it's if everything they do on their side is correct, then that's why you kind of have insurances for the unforeseen events. So that's when it would work as a people investing in the best practice, but getting the best terms essentially.
Another one here. How much more expensive is tracking compared to fixed tilt?
Yeah, so I think it does. I don't have the numbers to kind of to hand, but it does come with an increased cost on more of the kind of capital costs in the initial investment of the project. So there's kind of generally comes with, even though there's like, you might not have 2 posts, it's just I guess maybe a single post, there's still generally needs to be a greater amount of kind of structure and structural engineering into the ground. These are powered by kind of motors or slew drives, so there'll be a cost investment in that. They need electrical power, kind of an auxiliary power. So there will be a higher capital cost, but the operations and maintenance costs are coming down. A lot of panel manufacturers will maybe offer something in which they don't need to tie into the main like electrical system for the rest of the site. So sometimes they have their own solar panels almost on the tracker system to power them. So the operations maintenance cost, as this develops and the technology improves and tracker manufacturers learn from kind of working with projects that, yeah, they become more cost efficient with time, and you will make those gains back incredibly quickly for a large site. I think I showed the figure earlier, it was nearly 80% efficiency gains that you'll get from it. Sometimes you see figures up to like 40% increased power production. They can be optimized for also cloudy weather as well as moving with the sun. So yeah, it's that initial higher investment, but there'll definitely be information about that that's probably available on the web about the actual costs.
Thank you. I can see another question here from Melusi at Marsh. I know you can't name and shame manufacturers, but from experience, have you seen a specific tracker manufacturer that is doing well in resisting both hail and wind?
Yes, there definitely is. Within our reports, we worked with a tracker manufacturer, Next Tracker, who were very helpful kind of providing information and sharing data. And they have shown effective results in resisting both hail and wind. They're largely used within Texas and have been deployed effectively within other hail exposed states in the United States, and are kind of growing out globally because there's more interest coming from Europe on using trackers to kind of maximize energy from projects, but also for these types of exposures, like we mentioned, Italy and Greece. And I'm sure there's also some, like it might be as well somewhere South Africa that they're operating. So yeah, there's different tiers of manufacturer with different amounts of experience with these things. So yeah, there's plenty of really quality manufacturers out there.
I know Next Tracker's American based. Do you know if they're starting to look at South Africa with the exponential growth in this region?
I can't say for sure for them, but I definitely would recommend, if you're interested, reaching out to them. They really enjoy engaging and sharing information, and I wouldn't be surprised if they're already involved in South Africa. Are you aware?
I'm not Next Tracker specifically, but yeah, I mean, they're certainly one we'd definitely recommend.
And they are global, and I think they operate outside the US now, so with their products.
Oh yeah, Johan's just said they are.
Yes.
In South Africa and very fast.
Nice.
There we go.
Thanks, Chris.
Fast. There we go. Yeah, you got lots of good comments, you two. So thank you very much. It's very informative. As I said before, I think maybe there's another Q&A question, but I think we can start wrapping up.
We could try one more. Do a speedy answer.
We've got 30 seconds.
No, I can't find any more unless you can find some in the chat.
Yeah, a lot of good feedback. Thanks, everyone.
Thanks.
Smashing presentations.
Yeah, I saw the smashing one. So there we go.
Thank you all very much, and hopefully that was informative. And apologies again for the late start.
Slight technical difficulties. So
it's fine. I'll send you an invoice. It's okay.
Cool.
Well, thanks for making your time and all the hard work you put into that data and that research and that report. It's great. Yeah, sure. We'll send it to the brokers afterwards. You don't mind being recorded, hopefully?
That's fine.
That's fine. Yeah.
Yeah. Well, we can send it to everyone that's interested. But yeah, have a great day and thanks. All the best. Thank you, everyone, for attending, and have a great Tuesday.
Thanks.
Thank you.
Ciao. Bye.
Bye.
Bye.